Good day. So today we are to discuss radian or the radian measure. But before that, let us introduce the other angle measurements. So for example, we are to consider one complete rotation. So one rotation is the same as 2 pi. This is in radians. So we have also, this is the 360 degrees. This is the sexagesimal system. Then you have, this is the 400 grads. This is for the centesimal system. And we have also, one complete rotation is the same as 6,400 mils. So these are the other angle measurements. So for example, we are to convert, let's say 90 degrees. And we have to convert this one to radian. All we have to do is multiply pi divided by 180 degrees. So this is the same as this is pi over, that is pi over 2. For example, we are to convert 90 degrees to the centesimal system. 90 degrees, this is multiplied by 400 grads is to, we have 360 degrees. So this is the same as 100, this is 100 grads. So 90 degrees in the sexagesimal system is 100 grads in the centesimal system. How about 90 degrees to mils? This is, we have 90 degrees, we are to multiply, we have 6,400 mils is to 300, this is to 360 degrees. So what is 90 times 6,400 divided by 360 degrees? That will be the same as, so what is 1/4 of 60 is 1,600 mils. So these are the other measurements for angles. But now let us talk about more on radians, since we use the radian measure to compute the length of an arc, or to compute the area of a sector of a circle, or the segment of a circle, and so on. So let's have more discussion about radians. So for example, we have this sector. So basically, sector is just a portion of a circle. How do we express our angle in terms of the radian? So for example, we have this arc. Now it is, let's say our arc is S, then the radius of this sector as, say, let's have it as R, and its corresponding central angle theta. So let's have this as the point O, or the center of the circle. So we can have the central angle in radian. So let's say this is theta radian is the ratio of the arc length to the radius. So for a circle, how do we compute for the area of a circle? So the area of a circle can be computed as we have the area is equal to pi times the radius squared. So for the case of a sector is just a portion of a circle. So therefore we can have it by ratio and proportion. The area of a sector corresponds to a central angle theta. But for a circle is complete. Its angle is, or again, if we say one rotation, this is, its angle is the same as 2 pi. So area of a sector, it corresponds to a theta less than 2 pi. And the area of a circle corresponds to a complete rotation, that is 2 pi. So we can have it as the area of a sector divided by theta, what is the equivalent of the area of a circle, that is pi r squared divided by 2 pi. So we can cancel pi. Then we have the area of a sector is now equal to, by cross multiplication, this is theta divided by 2 times the radius squared. Or we can have it as the area of the sector is equal to 1/2. The theta should be expressed in radians multiplied by the radius squared. So this will be the formula for the area of a sector. So this is the area of the sector. So a basic example for a sector is one slice of a pizza. Okay, how do we compute for the arc length? So from this one, we have the arc length. The arc length S is simply equal to your central angle should be expressed in a radian multiplied by your radius. So that is for a sector. So what is a segment? The segment of a circle. The segment of a circle, for example, we are to draw a line from this point of intersection of the radius and the arc. The other point of intersection. Okay, this portion is called this is called as the segment of a circle. How do we compute for the area of a segment? Alright, the area of a segment of a circle is simply equal to, this is the same as the area of a sector. Alright, you can have it as the area of a sector. All we have to do is remove the triangular part. So, area of a sector, remove the triangle, that will be the area of the segment. So, area of a sector minus area of a triangle. How do we compute the area of this triangular portion? So, we can have it as the area of the triangle as 1/2 of AB sine of theta. You're familiar with this equation. But for this case, your A is R, your B is the same as R. That is the adjacent sides, or we have these two adjacent sides. Then we know this angle in between, or the included angle. So we can have the area of the triangle as 1/2. A is equal to R, B is equal to R. So it's the same as R squared, the sine of theta. So we can simplify this formula for the area of a segment. The area of a segment is equal to area of a sector, that is 1/2 theta radians, the radius squared, minus area of a triangle, 1/2 R squared. This is sine of theta. So actually you can also factor out the 1/2. This is 1/2 R squared. This is 1/2 of R squared multiplied by the theta radians minus the sine of theta. This formula is applicable for this type of segment. So let's have examples. So let's have some examples. So first of all, we have this sector with a central angle of 60 degrees and the radius is equal to 5 centimeters. So we are required to compute for the arc length, the area of the sector, and the area of the segment. So how do we compute for the arc length? This is the arc length is equal to the central angle should be expressed in radian multiplied by the radius. So we have arc length, theta radians. We have this is 60 degrees. How to express this one into radian? This should be multiplied by. We have to multiply this one to pi over 180 degrees. I multiplied by the radius. We have 5 centimeters. So you have to cancel the degree unit. We have the arc length. This is the same as pi over 3 multiplied by 5 centimeters. So we have the arc length as 5 over 3 of pi centimeters. So this will be our answer. That is the arc length. Then letter B. So for letter B, we are required to compute for the area of the sector. So area of a sector is equal to 1/2 the central angle in radian multiplied by the radius squared. So we have this is 1/2. What is our central angle? We have 60 degrees multiplied by pi over 180 degrees. This is multiplied by the radius. We have 5 centimeters squared. So we are to simplify this one. This is the same as 1/2 multiplied by pi over 3 multiplied by 25. So you have, this is the same as 25 over 6 of pi centimeter squared. So this will be the area of the sector. Now, computing for the area of the segment, so you have letter C. So the area of a segment is basically the area of the entire sector. This is the area of the sector minus the area of the triangle. We have the equation. This is the same as 1/2. This is theta radians multiplied by the radius squared minus 1/2 the radius squared sine of theta, or the simplified form. We can have it as 1/2 radius squared multiplied by theta radians minus the sine of theta. For this case, we have 1/2. What is our radius? We have 5. This is 5 centimeters squared. We have to express our central angle in radian. That is 60 degrees multiplied by pi over 180 degrees minus the sine of 60 degrees. So this will be the area. So let's have it as 8.5 or 1/2 of 5 squared. Multiplied by pi over 3 minus the sine of 60 degrees. So we have the area as 2.2 as 65 square centimeters. So that is the area of the segment on this portion. We have the area of this segment equal to 2.265 square centimeters. This will be our example. So let's have this example. For example, we have this sector. Then we are to draw a line segment from the intersection of the radius. So the radius of the sector is 4. From the intersection of the radius and the arc, we are to draw a line segment towards the midpoint of the radius on this side. So how do we compute for the area of this? We may say that this is an irregular segment of a circle. So still, we have to follow the concept. How do we compute for the area of the segment of a circle? When we have the area of a segment is equal to the area of the sector and minus the area of the triangle. Okay, so we have the area of the sector is 1/2 the central angle in radian, the radius squared minus 1/2. This time we cannot apply 1/2 r squared sine theta for a reason that we have an irregular segment. We are applying 1/2 AB sine of theta. So we have here what will be the value of the A and B. So let's say this is our sector. To have this area of this irregular segment, all we have to do is remove the area of this triangle. So therefore, we are to use A, that is the same as our radius, that is the 4 centimeters, and B will be the 2 centimeters. So we are just to remove this triangle. So we have to substitute. This is equal to 1/2. What is our central angle? That is 30 degrees multiplied by pi divided by 180 degrees multiplied by the radius squared. The radius is 4 squared minus 1/2. What is the value of our A? One side of the triangle, that is the radius 4 centimeters. The other side of the triangle is 2 centimeters, and the included angle is the same as 30 degrees. So we have the sine of 30 degrees. So let us compute for the area of the segment. So that is 1/2 of 30 degrees times pi over 180 to be in radian, multiplied by the radius of 4 squared. So that is the area of the sector. Less this triangle, that is 1/2 of 4 by 2, then sine of 30 degrees. 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 Okay, so we have the area equal to 2.189 square centimeters. So this will be the area of the regular segment. And so let's discuss circular motion. To describe the rate of rotation of a body in a circular motion, we use the angular velocity. So this is in terms of the omega. So one rotation, our angular velocity is, one rotation is 2 pi radians, divided by the time to complete one rotation. So for example, the time is in seconds. So we can express angular velocity in terms of the radian per second. So basic units for angular velocity, it is the same as the radian per second, or we can have it as the revolutions per minute. Okay? So for example, a body following a circular path is about to, let's say, leave the circular path. It will follow a straight line or a straight path. So we call this in physics as the tangential velocity. So tangential velocity, how do we compute for this one? So tangential velocity can be computed as your angular velocity multiplied by the angular velocity multiplied by the radius. So this is the value of the tangential velocity. So let's have an example. So let's have an example. For example, we have this wheel having a radius of 2.5 feet. And it is rotating at 120 RPM, or that is the revolutions per minute. So we are required to compute for the angular velocity in radian per second, the angular velocity in degrees per second, and the linear velocity of its ring in mph, or that is the miles per hour. So we have the first one. This is letter A. We have the angular velocity is given as 120 RPM, or this is the revolutions per minute. All you have to do is convert this one to radian per second. So we are multiplying. This is, we have 2 pi radians is equivalent to 1 revolution. Then multiplied by, we have 1 minute is the same as 60 seconds. So we can now have the angular velocity. If we are to do unit analysis, we may cancel revolutions and minute. Remaining units will be the radians per second. So that will be the same as 120 times 2 pi, that is 240 pi divided by 60. That is the same as 4 pi. The units now is radians per second. So that will be our answer for letter A. Then we have letter B. We are required to have the angular velocity in degrees per second. So we have now angular velocity. We have it in radian per second. This is 4 pi radians per second. All we have to do is multiply this one by, we have 360 degrees is to 2 pi radians. So we can cancel the radian unit. We have now the angular velocity. One is 4 pi divided by 2 pi, that is 2 times 360. We have now the unit 720 degrees. 2 times 360 is 720 degrees. That is per second. And this is our angular velocity in degrees per second. Then lastly, we have letter C. Linear velocity of its rim in miles per hour. That is the same as the velocity of a point farthest from the center. If we say linear velocity, that is the same as the tangential velocity in physics. So what we have to do is the tangential velocity, that is the same as the linear velocity of its rim, that is the angular velocity multiplied by the radius. So if you are multiplying angular velocity to the radius, you should use the radian per second. So we have, this is the same as 4 pi radian per second multiplied by minus the radius. We have, this is 2.5 feet. So this is the same. Our tangential velocity is the same as 4 pi times 2.5 is now 10 pi. This is 10 pi feet per second. Take note that radian will adapt the unit of the multiplier. So radian times feet, we are to adapt feet since radian is the same as unitless. But the required unit, is miles per hour. We're just to convert that one. So we have the tangential velocity is equal to 10 pi. This is in terms of feet per second. We are multiplying. We have 3,600 seconds is to 1 hour. Then multiplied by, we have 1 mile is to 5,280 feet. So we have now the equivalent of the linear velocity of its rim. We are cancelling feet. Then the second. So remaining unit will be mile per hour. So this is the same as 10 pi. I think we need our calculator. So this is the same as 10 pi multiplied by 3,600 and divided by 5,280. We have that as 21.42. This is now in terms of the miles per hour. This will be our answers. So we have letter A is 4 pi radian per second, letter B 720 degrees per second, and letter C linear velocity in miles per hour is 21.42 miles per hour.